predictive modeling, machine learning, and so on and so forth. So as Hope has said, let's do some theory before we go into the practice. The understanding of those theoretical parts, they are extremely important to understanding how you navigate yourself through nine. So I'm going to ignore this part. So NIME itself, so one of the key functionality of NIME is that it has inbuilt functionality for what we call machine learning. So before now, so when people mention the word machine learning, artificial intelligence, they used to piss me off. Like that was like maybe 5 years, 6 years ago. When people say machine learning, it pisses me off because I just felt maybe machine learning must be okay. You need to, like maybe self-driving car, the way when you put intelligence into a robot, and maybe the unmanned air vehicle, like drones. The drone can just fly to a particular location, deliver a message, and come back. But at times it does not really have to be that sophisticated. It doesn't have to involve a lot of robotics in it before you can really build a machine learning or an AI solution. Even your Excel has that functionality. Even your phone, when you're trying to type messages on WhatsApp, automatically your text message, or the text message platform, the WhatsApp platform, will automatically predict um, the next words you're about to type. It's some form of artificial intelligence. It's predicting. In some cases, it will be correct that is what you want to type. In some cases, it will not be correct. Those are predictive models. Those are use cases for predictive model, and it's applicable in many cases. And what makes that happen? The algorithm that makes it happen is called machine learning algorithm. So let's start from that theoretical part before we flow into nine. I hope that time will allow us. I have 1 hour to do this before I hand over to Hope. So machine learning is just a combination of statistics and mathematics, essentially to draw insight from data or to make prediction. So for instance, if everybody in a class, for instance, if a class is primary six, for instance, if I bring a child for primary six that this guy is in primary six, you can tell by default that okay, his age is likely going to be either age 5 or age 6. Maybe he's more than 5 or a little more than 6. If I tell you that somebody is in primary 5, the same way if I tell you that somebody is in GSS1, you'll be able to predict, okay, maybe he's either between 10 years and 12 years old. So that it's prediction. The same thing happens. We can build that type of intelligence into many things that we do in our everyday life. You can build that kind of intelligence into your car to know when the car should stop, to know when the car should start. You can build that kind of intelligence into your TV. You can build that kind of intelligence into a mobile banking application, into a banking platform, into an insurance solution, and so on and so forth. So machine learning essentially is a subset of data science that deals with statistics and mathematics. And there are like 3 different broad categories of machine learning. One is supervised model, the other one is unsupervised, and the third part is reinforced model. So when it is supervised model, you have an idea of what the possible outcomes will be. So for instance, MTN, or I used to work in MTN before. Hope used to work in Etisalat before. So there is something we used to do in those places. So we want to predict, okay, who are the people that are likely going to recharge tomorrow? So if you can tell that a customer is likely going to recharge within a particular time frame, then you can how do I say it? You can now give that customer some campaigns. You can give the customer some campaign that will make the customer recharge more than what he would ordinarily recharge. So maybe I normally recharge, I buy 1 gigabyte. I buy 1 gigabyte for 1,000 naira, for instance. So you can tell me, So at that rate, you will expect that maybe 1.5 gigabytes will be 1,500 naira. But because you already know that I'm going to recharge, they can send you an incentive below the line. It's not available to everybody. That okay, oh, this guy is going to recharge tomorrow. Normally he recharges 1,000 naira. Let's give him an offer. Let him recharge 1,500 naira for let him recharge 1.5 gig for 1,200 naira. So in that way, you are trying to upsell the customer. You know, that is what you are trying to do. You are trying to upsell the customer. So that is supervised. So you are trying to upsell the customer. So now, if you are now building a model that determines will a customer recharge or will a customer not recharge, that is a predictive model. If you are trying to build a model that okay, will somebody fall sick? Will a patient, if a hospital is trying to predict, will a patient complain about malaria, or will a patient be admitted for malaria, let's say next week, after he has been treated for malaria, will this patient come back or he will not come back again? There are models like that. It's a supervised model. The outcome is already known. There are unsupervised models where the outcomes are not known. So things like clustering, segmentation, I think I'm going to get into some of that. Then you also have reinforced model. Reinforced model are things like when you are building things like a self-driving car. You learn through trial and error. You learn through trial and error. So I want to build a model. I want to build a simple robot that will find its way from where I'm sitting now and find its way outside. So if I build that model, each time it hits a brick wall, it will learn that okay, this is not the way to go. Then to keep moving back and forth, finding the path that will lead it to the final destination. So reinforcement model is exposed to is the environment that trains in the reinforcement model is the environment that trains it. So over time, it learns by itself how it should navigate or how it should not navigate through past experience. And each time it encounters an obstacle, it gets a penalty. And each time that it successfully achieves a task, then it gets a reward for that. You know, and its brain is updated. So and there are different classes of this supervised and non-supervised model and reinforced model, as I have said before. Then now that is a broad categorization of the different models. A broad categorization of different models. Now there are specific models for specific kind of operation. So look at it this way. You have I like this example. You have an ambulance, you have a towing vehicle, and then you have a regular vehicle. So let's assume, for instance, a car broke down on the highway. You can use an ambulance to tow that vehicle, but that's not an ambulance. That's not what an ambulance is meant for. You know, that's not what an ambulance is meant for. But you can manage to use an ambulance to tow the vehicle. So in the same vein, there are some specific tools that are best fit for some specific operations. So when you are performing supervised model, there are some specific algorithms that are fit for that supervised algorithm. When you are doing unsupervised, there are specific algorithms for unsupervised models. When you are building a reinforced model, there are specific algorithms for reinforced model. So if I want to predict whether a customer will churn, a customer will not churn, because what I'm predicting is like categories. You know, I'm trying to predict different categories, and because I'm trying to predict different categories, it's called a classification model. You know, if I'm trying to predict a number or I'm trying to predict a date, if I'm trying to predict a number or I'm trying to predict a date, that is called it's called a regression. If I'm trying to predict a number, it's called a regression kind of a problem. Then if I'm trying to say I want to group things, you can also write a model that will just group things together into different categories, into different clusters. It's called clustering. There are a whole lot of use cases for these different models and algorithms. There are so many business application use cases in bank, in insurance. So sometime in 2014, 13, 14, my company spent about maybe then $1 million to build something that is called a segmentation. Then the company had about 23 million customers, but they want to group those customers into different clusters. They want to group them into different clusters. 23 million. So it's a huge task to group 23 million unique individuals into different clusters. So those clusters or those clusters will help them to create products. So those clusters will be based on demographics, psychometric attributes. So demographics like what is the age group, what is the gender, what are the lifestyle choices, what is their adoption tendencies for new technology. Are they leaders? There are some people, if there's a new technology, there's a new framework that is out, they are the first set of people to adopt it. There are some people, they will have to wait and make sure that everybody has adopted it before they adopt it. That is like clustering people together into different groups. That concept is called segmentation in the corporate environment. Its data is purely based on data. It's based on the behavioral analysis, demographic analysis, psychographics analysis of data generated from those different individuals that is used to achieve all of that. Now, there are machine learning algorithms that facilitate that, because if you want to do for 23 million people, at some point, if you are doing it one by one, imagine if you are doing it, you are taking one customer one by one manually. You imagine how long it will take you to be able to do that. So, of course, the researchers now decided to develop a machine learning algorithm that can actually facilitate that. So you have linear regression, you have logistics regression, you have k nearest neighbor, you have random forest, you have decision tree, you have naive Bayes model, you have k means, you have random forest, you have neural network, and so on and so forth. There are so many more than all of these that I have mentioned. There are a whole lot more than all of these. There's a particular tool that I use. It's called Data Robot. I'll quickly check Data Robot. Yeah, Data Robot. Yeah. So let me see if I can share Data Robot. Data Robot has more than 100 different types of algorithms. Some of them I've never even heard about them before. So they have like a research lab where guys are seated day and night and building new kind of algorithms, So some of those algorithms, they are adaptation of what you already, with some of these ones that you have there. So you can have, they can combine decision tree and random forest in a way and call it, or maybe they can combine decision tree and linear regression together in a way and call it decision tree regressor, or they can combine random forest and linear regression together in a way and call it random forest regressor, and so on and so forth. So they have created different kind of algorithms, which is a combination of multiple different type of algorithms, which is what they research people. So if you decide to go and do like a PhD in data science, of course, those are some of the fantastic PhD topics, where you can see that, okay, whenever the model that you build, whenever it's applied on a particular type of data set, it kind of perform a lot better than when the traditional one it's applied. That said in a nutshell. So let's look at this theoretical part. Again, I said linear regression. Linear regression is for predicting real numbers. Maybe you want to predict. So if let's say Zenith Bank engages us today, and again Zenith Bank says that, please, can you predict for us how much new customers are we going to acquire in some locations in Nigeria? So how much new customers? Because the number of customers that they acquire is going to determine maybe how many new branches they should roll out, for instance. So they want to make about new branches that they should roll out. So they gave you the history of all of their acquisitions. So over the past 10 years, this is the number of customers that we have been acquiring on a daily basis, week in, week out, month in, month out for the past 10 years. They gave that to you in different locations. They now said, can you help us to predict how many new customers are we going to acquire in the next 1 year, so that we can use that to plan our branch rollout or our ATM deployment? That can be the challenge that they pose to you. So if you are posed with a challenge like that, what they're asking you to do is to predict numbers. And in problems that you need to predict numbers, is a regression kind of a problem. It is supervised algorithm in the sense that what needs to be predicted is already known. It's numbers. You know the outcome is number, and there's a simple formula for that. But of course, when the degree of the determinants, when they continue to grow, when the degree of determinant, when they begin to grow, then the formula becomes much more complicated. But as much as possible, what mathematicians, all the algorithms itself, all of those algorithms can be reduced into a mathematical equation. For regression, there's linear regression, there's exponential regression, there is polynomial regression, and so on and so forth. There's exponential regression, and so on and so forth. There are so many regression, but most of the time, in most cases, what they try to predict in a regression problem is a number. So then we have what is called decision tree. Decision tree is something that you probably have done before, or something that is part of your everyday life. So how decision tree works is like so decision tree is like an if-else statement. So for those of you that do programming, when you want to write if-else statement, so if you have only 5 variables or less than 5 variables, and you want to do if-else statement, maybe Hope has thought of about POPR, where if the average of what a customer was doing before compared to what the customer is doing now, it is greater than maybe a particular percentage, then you classify the customer as a grower. If it's less than a particular value, you classify him as a dropper, and so on and so forth. Now, if there are just 5 or 6 variables, you can easily code that on your computer. You can easily code it. But imagine if there are like maybe 1,000, if there are 1,000 variables, if there is 1,000 possible scenarios or 1,000 possible combinations. You know, when you have 1,000 possible combinations, at some point you will look, if you are doing that manually or if you are coding it manually, you might be lost. You know, you'll not be able to catch up with it. So in that case, they now build decision tree algorithm where you can now begin to be splitting your decision based on if an entity meets a particular condition. You know, you start building your tree, or you start training your tree based on whether a customer meets a particular condition or not. It's probably what a lot of you guys are very, very conversant with. You might have done it before. If you have ever programmed, you have written if-else statements, you have done decision tree before. But in this case, when you now have a data set, so if you come to the banking environment, for instance, you can have a data set that has like up to like 100 different variables, and you want to do if-else. You want to do if-else on that data set that has about 100 features. So at some point you will be lost. So decision tree gets it done for you. Hopefully today we'll be able to use K9 to demonstrate decision tree. Now, random forest. So random forest is like a combination of multiple decision tree. As they normally say, that a tree does not make a forest. So that is exactly what is happening in random forest. So random forest is a combination of multiple trees, So if, for instance, look at it this way, there are 5 of us in a class, or meaning there are 200 of us in a class. So they ask us to predict, give a model if um, if any one of us would say if any one of us would travel this summer or not. So an airline or a travel agency, they want to know if people in the class will travel for summer or whether they will not travel for summer. So you understand why they want to do such a model is that if the tendency that you will likely travel for summer is very, very high, they will send you campaigns, they will send you offers, they will send you travel offers, they will send you coupons so that you can use their own agency to buy your ticket and to book your hotel. Now, 200 of us in the class, if you apply a decision tree, you're just going to scan through the data once and then come up with a prediction that, okay, Blessing will travel, Ibitamuna will travel, Sunday will not travel, and Henry too will not travel because they are doing DASCA, stuff like that. But that will just navigate through it once. It will scan through the population once. But in a random forest, there are multiple decision trees that will scan through the data set multiple times. So in some cases, a decision tree can predict for Blessing that Blessing will travel. Another one will predict for Blessing, no, Blessing will not travel. Then another one again will predict for Blessing, Blessing will travel. So maybe out of 5, 3 predicted that Blessing will travel. Then 2 predicted that Blessing will not travel. Then at the end of the day, we'll now cast a vote based on the majority. Okay, we have 5 decision trees, 3 predicted that Blessing will travel. So because of that, we want to 3 predicted Blessing will travel. So because of that, we want to conclude that Blessing will travel because the majority of the prediction concerning Blessing from the decision tree is that he will travel. So it assembles multiple decision trees, and it then makes a decision through a vote, through a vote. Some people call it what do they call it? Cat. Some people call it cat. What is that cat? Hold on. Let me quickly check it out. Cat trees. Some people call it cat tree. So in decision tree and random, some people call it cat tree. So if you also hear some other people making reference to cat tree, C-A-R-T tree. Don't be lost. They are still making reference to. They are making reference to. They are still making reference to random forest of decision tree. It's called classification and regression tree. That is cat tree for machine learning. It is still like decision tree and random forest that they are indirectly making reference to. Yeah. So moving on. Then you also have K-means. So K-means is a supervised model where we try to predict whether a particular entity belongs to a particular data set. And the way it does it is that it's kind of K-means is like, okay, this is which how do I put it now? So if there are different categories, if there are like 5 different categories, or if there are 5 different categories, and you now have an element that you want to predict which category does it belong to. So we can look for the nearest, the K nearest neighbor, the K nearest neighbor. So look at this diagram on the screen. Look at this diagram on the screen. So we want to predict that for this black entity that is here, for this black icon that is here, how do we classify it? Do we classify it as red? Do we classify it as green? Or do we classify it as yellow? So the classification will be based on its nearest neighbors. So thank you for muting your microphone. Okay, so the classification will be based on the nearest neighbors, So If so, first of all, in trying to set for k nearest neighbor, some of the parameters you need to determine is maybe something like a radius, something that is called a centroid. Then the k means how many neighbors do you want to consider? How many number of neighbors do you want to consider? So you understand. So k nearest neighbor. So how it works is that, so for this black icon, for instance, based on the radius that you have determined or the centroid that you have set, if you draw that radius around, if you draw that radius around this black icon, or how many of the neighbor are within the circle that will be formed by that radius that you want to create. So in this case, you see that like three green fell into the radius, like 2 yellow fell into the radius, and there's no red that fell into the radius. So based on this, if you want to classify this black icon, we can classify it as a green, So now, how can this be applied? When you take a website, you want to determine whether a website is a legitimate website, or whether it's a suspicious website, or whether it's a phishing website, or maybe it's a virus website. You want to classify it. But this website, you have classified multiple websites, you have classified multiple websites in the past. So you know the ones that are legitimate, you know the ones that are probably suspicious, you know the ones that are virus sites, for instance. So there is this new website. That website is octaveanalytics.com. So for the first time you're encountering this website, the application is encountering this website. How do you classify this Octave Analytics website? So, but you don't know any information about it. But you can now pick some parameters from that website and now check. From the parameters I have selected from this website, maybe the domain, the domain, the DNS, or the platform that is hosting the website, the country of host of the website, the content on the website, some of the kind of images on the website. You use different parameters to now see, okay, based on all of this information, is it a legitimate website or it is not a legitimate website? Is it a suspicious website or not a suspicious website? Is it a phishing website? So based on all of that, so from all of the data sets that you have collected on Octave Analytics, based on that, you may want to reach a conclusion. I think to a very large extent, it is closer to a legitimate website than anything else. So more or less that's how that's how k-means work. That is how k-means work. What is it close to? That's how that works. Give me just 30 seconds. Please ask me a question if you have any question. Please feel free to ask me any question. Any questions, please? Or I'm just the only one that is talking?
No, you're not the only one talking. We can hear you.
Yes, sir.
Okay, thank you. Okay, so let's proceed with let's proceed. So that is how k-means work. Of course, this class is probably too short for you to understand the theory of all of these concepts. So I recommend that you read up on all of these concepts later on. It's definitely going to help you to know how to use different tools. So K means K nearest neighbor is supervised. It's supervised in terms of we know the number of the different classes that we want to determine, or we know the number of different classes that are available. So for a website now, It's either it's a legitimate website or a suspicious website or a phishing website. We know the outcomes. We know the possible outcomes. You know, even though there are just 3, but we know the possible outcomes. But when it comes to K-means is unsupervised and it's a little bit different. The concept around K-means is different. So K-means is that, okay, in our class, there are 200 people in our class, for instance. I say, okay, just group those 200 people into 3 different segments or into 3 different clusters. So that concept is called clustering. Okay, cluster these people into 3 different groups. So you might just look at if some features that they have in common, and based on the features that they have in common, you use the features that they have in common to group them into different clusters. Or of course, definitely you specify the number of clusters that you want to create, because there is an infinity number of clusters you can probably create. But the properties of the elements in each cluster, you don't know. Now, when you come to K-means, for instance, why K-means is supervised is that the properties of legitimate websites, you know. For suspicious website, the properties of suspicious website, you know. For phishing website, the properties of phishing website, you know. But when it comes to K-means, if you group a data set or a population into 3 different categories, for instance, the properties of each cluster or each subset, the properties, you have to now analyze it to know what they have in common. You know, you have to analyze it. You will not know. So you are leaving it to the algorithm. Algorithm, take this data set and group them into clusters for me. So group them into clusters for me. After grouping them into clusters, then you now come and now do exploratory data analytics, you know, using your R or your SQL to look out for the different features in each of the clusters that have been created. Again, all of these have application in everyday life, especially in the corporate setting, or especially in businesses that have like customer bases. They have corporate, they have classical use cases that you can apply them to, and so on and so forth. There are so many of those machine learning algorithms. They are all applicable in process automation. They're applicable in security. You know, when you want to build a security system, in underwriting, that is insurance, and in credit scoring, in trading, even for the guys that are doing online trading. At times you hear people talk about cryptocurrency, Bitcoin, you hear people talk about Forex, and they will tell you in Forex, they will tell you that they will tell you there's a time to buy, there's a time to hold, there's a time to sell. You know, they'll tell you. So there are robots, they call it robo marketing or robo something. They call it some robo trading in essence. So what they do is that based on the pattern, based on the historical trend that the data has formed, you know, like your regression, based on this pattern that it has formed, we can tell that, okay, this particular stock is going to go up or whether it's going to go down. They can tell whether it's going to go up or it's going to go down. So when you put your money, they will tell you, when it gets to this point, remove your money, because after this point, it will start going down again. So you should better withdraw your money. So if this is not done in Nigerian Stock Exchange, so if we can collect the data of Nigerian Stock Exchange, some people here can be billionaire. If you can apply some of these algorithms on Nigerian Stock Exchange, it will help you to determine how you should trade stock in Nigerian Stock Exchange. If you can collect that data on a daily basis over a long period of time. Those are some of the applications of machine learning algorithms. The applications are uncountable. You can just wake up tomorrow and think about a new way you might wake up tomorrow and think about a new way you might want to apply the machine learning algorithm, you know. So yes, any question before I move on? No question. Thank you.
Sir, no question for now, sir.
Okay, thank you. Let's proceed with our proceedings. Okay, so typically when you now want to build a model, so the question is that if they now tell me, oh yeah, Blessing, come and build a model, what are the different steps I have to follow? What are different steps that you have to follow in order to build a model? And this particular slide here is summarizing it's summarizing everything that you possibly it's summarizing everything you possibly have learned, or it's summarizing how to apply everything you possibly going to learn under this graduate training program. This slide is summarizing it. So let's give an example. I'll give you an example. TPM. Okay, so sometime in yes, so sometime in 2017, NTN asked Octave Analytics, okay, Octave Analytics, please can you build us a dormancy prediction model? So dormancy prediction model is that, okay, Blessing or Octave Analytics, we have an issue. We are losing customers, and we are losing customers at a very, very high rate. It's a problem for us because we are losing too many customers. How do we reduce the rate at which we are losing these customers? So one way you can apply data science in doing that is by building what is called a dormancy prediction model. So while a customer is still very much active, you may want to tell whether that customer is going to churn. Even though the customer is still active, but we want to tell before now if that customer if the customer is going to churn, though the customer has not churned yet, because the customer might even still make a call today. You can have a customer that will go to the bank today to go and generate a transaction. But from the transaction pattern of that customer, when you analyze it, you can tell that this customer is on his way out. It's about to. So if the guy went to bank, but he withdrew all his money, you might be seeing it as an active customer because he went to bank to generate transaction. But the kind of transaction that he generated, it's an indication that this guy he's angry with the bank and he's withdrawing his money. I think he's taking it to another bank. So we want to build a dormancy. So the challenge is build a dormancy. How do you build it? Applying these machine learning algorithms and also applying 9 in order to solve the problem. So the first step you need to take, back to the second slide. So the first step you need to take is to do what is called data preparation. So you've been learning SQL, you've been learning R. So all of those concepts that you've been learning in SQL and R are purely applicable in your data preparation. So for the MTN example, for instance, for every phone number, for us to determine whether they are going to churn, what are the features, what are the variables that we need to collect on a particular phone number? So we might be interested in the date of activation of that customer. That means the date the customer became MTN customer. We may be interested in the last activity performed by the customer. We may be interested in how much the customer has recharged on a monthly basis for the past 3 months or for the past 6 months. We might be interested in how much data the customer has bought on a monthly basis in the past 3 or 4 or 5 months. We might be interested in the number of people that customer calls. We may be interested in the number of people that call that customer on that line, and so on and so forth. So if I go on like that, I can go to 250 different features on a single phone number that you may want to collect to build this model. Basic features, very basic features that, okay, how many? in a month, for instance, how many what in a month, say in a month, how many days in a month did this customer make call with this phone? And I want that for like 6 months. January, February, March, April, May, June. In January, he made calls 20 times. In February, he made calls 50 times. I collect all of that on a monthly basis. Then again, I can check it in terms of relativity. How is the customer performing now compared to how the customer was performing before? So I collect a whole lot of possible then variables on that one single customer. That is data preparation. And of course, your R and your SQL are the tools that you use to do that part. Then the next part is for you to now do what is called so there are some variables that are called, you need to be able to classify some of those variables. There are some variables that are global variables, while some variables are variables that change. So for that phone number, for instance, the date of activation of that phone number will always remain constant for forever. Forever, that date of activation of that phone of that particular customer. So if you activated that, if the date the customer bought that SIM is the 1st of October 1960, it will never change. But there are KPIs that how much the customer recharged in October may be different from how much he recharged in November. How much data he consumed in October will be different from how much data he consumed in November. The number of people who called in October, and so on and so forth. So those are monthly variables. So for that single phone number, you need to create like all of those features and be able to differentiate them, some as global variables, some as monthly variables. That is where you do most of your work. And that is why we say the work of data engineer and the work of data analyst, this is where their work align to a very large extent. In this case, in fact, it's difficult to differentiate who is a data engineer or data analyst because everybody is supposed to have that competence. Then the next part is now what is called feature engineering. So feature engineering, how it works is that you've collected a number of features, you've collected the customer's date of birth, but you don't even know the age of that customer. So you can use the date of birth with today's date to compute what is the age of the customer. You know the date of activation of that customer. So you may now want to compute how long has this customer been doing business with us. So from today, if you subtract the date of activation from today's date, you can tell how long, that the customer has been doing business with you. Then if you will now want to compare, okay, what is the customer doing now compared to the average of what he has done in the past 2 months or in the past 3 months. Based on that, you now classify the customer into different segments. Is it growing or is it dropping, and so on and so forth. Those are new features that you are creating on that single phone number. That is called feature engineering. So all of this process is called feature engineering. This is where you spend most of your time. In fact, to use K9 in 15 minutes or in 20 minutes, if you have a powerful computer, you can be done with everything that needs to be done with K9. But you can spend 2 months in trying to prepare your data and making sure your data is good to go. Even after you have done it, you may need to go back to that data and refresh it and tweak things here and there. So after feature engineering, you now do what is called pre-analytics. Pre-analytics is what is called exploratory data analytics, and that is what Timilade is trying to show you. So with pre-analytics will help you to understand some of the nuances in the data set, some of those things that make sense in the data set, some of those things that you should discard in the data set. It's going to help you to throw up really relevant insight in the data set. If you have done if you have done ThinkCell before, so ThinkCell can help you to identify the relativity between what you are trying to predict and some of the features that you have created during your feature engineering and during your data preparation. Having done that, the next thing that you now do is what they call principal component analysis, or what is called principal component analysis, or what is called variable feature selection or dimensionality reduction. So even though we have created so many variables, we've created like 250 variables. It's not all of them that we are going to be putting into the model. So maybe if for that phone number, you have the activation date, you have how long the customer has spent on the network, for instance. They look alike. One, okay, date, that one is just date. It may not really be telling anything. But how long the customer has spent, it's some kind of information. The date of birth may not be any information, but the age of that customer, it's a lot of information. So with that age, you can group that customer into different age group and different age band. And one thing that we have seen in our experience is that customers behave differently depending on their age band. So the 18 to 24, they are tech savvy. They will go to internet, they check Instagram, social media, Twitter, while you have people from age 50 and the rest. Some of those people don't even care about Twitter. They don't even have an Instagram. They don't even have Facebook account. So, but remember, it is the date of birth that we use to create age. And it is the age that we now use to create the different age bands, Then we will now be drawing conclusion that, okay, customers within this particular age band, they tend to behave in this particular way than customers in this other age band. So when you look at it, for us to now build that model, we may no longer need the date of birth. So at some point, you might need to discard some of the features that you originally created in building your model. And that process is called variable selection, dimensionality reduction, principal component. So don't let those people scatter your head. They have so many things that they use to describe all of those things, but they are just simple concepts. You are just selecting the variables that you need for your model. And that process can also be called principal component analysis. So what are the principal components? So I'm analyzing them because I just want to choose the principal components in the data set. So having said that, then we now go to the realm of data partitioning, then now apply your machine learning techniques and so on and so forth. So now, ladies and gentlemen, I'll spend 15 minutes to move into the 9 demonstration. So this is like the workflow. This is the workflow. So do I have 9? So there are more details, but let me go to 9. So I'll launch 9 on my PC. I'll launch 9 on my PC and then I'll share my desktop. I'll share my screen to display 9. But feel free to ask me any question. Is the terminal on the call?
Yes, sir.
I have a question, sir. Hello? I have a question, sir.
Okay, please ask your question.
Can you go back to your flow chart, the flow chart? I have a question from number 4 to 5.
Okay.
Okay. My question is, after checking the global and monthly KPI selection, why do we have to go straight to the feature engineering before we now discard inconsistent data? Why not discard inconsistent data and return the KPIs before we do the feature engineering?
Okay, no. Okay, 4 to 5. Okay, so
It should be 1, 2, 5. 1, 2, 5.
No. So even after you have done feature engineering, some of the features that you have created, you may not still need them. You might still need to discard some of the features. So in feature engineering, you create additional features based on what you have. Some of those features, you might still not need them. So let me give you an example of it. I just gave an example of feature engineering. You have date of birth. You use date of birth to compute the age. You use the age to compute the age band. So at the end of the day, do you still need the date of birth? No, I think I don't need it. So you can drop it. Okay, do you still even need the age? Do you need the age? I already have the age band, so you can still drop it. So So it's a loop. When you look at it, it's a loop. So the fact that it's a loop means that anyone will come after the other one, but you do it iteratively until you are comfortable with the features that you have eventually created, and those features must have some level of data integrity and consistency in them.
Okay, thank you very much, sir.
Okay, so I'll disconnect this and share my screen. How do they share screen again? Pushimo is on this call. Okay, sorry. Yeah, he's one of the facilitators in this class. So I forgot. So where's my screen? It's not sharing, no. Okay, I think it's sharing. I don't know what you can see, but I'll check from my phone what you can see. Okay, so I think that means you cannot see my screen yet, or can you see it?
Not yet, sir. No, sir.
No, sir.
Okay, so I'm sharing again. Okay, so here is NIME environment. I call it K9. So please forgive me if I switch between NIME and K9. I'm just referring to exactly. I'm referring to the same shop. So so the NIME environment has different components. This is where Coke started, or this is the point where Coke wanted to start taking this. But why I had to go through those preambles is that it will help to grab some of the stuff we want to talk about here. So this is the NIME environment. NIME is a predictive analytics tool. So in NIME environment, you have the NIME Explorer. So the Explorer is where you access your local folders, you access the work that you have done. So on local, you can access your previous work that you have done. But it also has example workspace where you can access 9 examples. So the way they have done it is that they created a library of examples where you can quickly look at some of the things that have been done before. Then you have the node repository. So in trying to create um, models in nine, you need nodes. So it's node. So the same way when you call in R, when you call a function, so what they have done is that for people that really are not very convenient with programming, so there are functions. They've coded those functions into icons. You just need to pick an icon that has the functionality of the function that you need. It's very simple stuff. Then you have the workspace. You have the workspace, and I'm good. So this is like the workspace where you bring your icons and you build your model. You have a console. So console is where you get the output, or where you get if there's error, when you get feedback for the models that you are building. Then you also have the node description section. So the node description section is where you see um, a very short description on the node that you are calling. So for instance, so say we want to build a model, a dormancy prediction model, for instance. Of course, we would have prepared our data maybe on an SQL database. We would have prepared our data maybe on an Excel sheet or CSV format, Excel format, anywhere. The data could be somewhere. So you now need to bring some icon to read the data. So for instance, you need to read your data. So if I bring an icon, so here is an Excel reader. So if I have my data in Excel, for instance, with the Excel reader, I can connect to that data. So when I brought up Excel reader, you see when I brought Excel reader into the workspace, I'm deleting it and bring it back again. Bring it into the workspace. When you bring it into the workspace, you can see there's a write-up on Excel reader, the kind of input that it takes and the kind of output the kind of output that it gives. So it tells you the kind of input, the kind of output, and stuff like that. You can download Nine from the official website, nine.org. Yeah, I think nine.org. You can download Nine. It was developed by the university in Switzerland, in Zurich, in Switzerland. So let's look at some example. Let's look at a very classical example that's applicable in banking and in telco space. So I'm going to be using some of the examples, embedded examples in that's already in K9 or that's already in 9. It's launching those examples. Okay. Why is it now? Uh, I'm refreshing. It's strange. It's not coming up. Okay, so I'll check through my PC. Training. Okay. It's kind of slow on my PC. Okay, so I'll check absolute data. Okay. Okay, so I have this CSV file that I want to use to. I have this CSV file I want to use as my training file. I don't want to build this thing from scratch. I want to. I wish there's an example I would just load into the environment and show you how it works, but it's not kind of not loading. So first of all, whether it is, of course, you guys know whether it is R or whether it's Python or anything. The first thing you need to do is load your data into the workspace. You need to create a workspace and load your data into the workspace. So for me to load my data into the workspace, because my data is in CSV format, so I'm looking for a CSV reader. But the data can be in Excel format. Use Excel reader. If the data is on a table, maybe it's on a database table, you look for a table reader, So, but in this case, I'm looking for a CSV reader. So I load CSV reader into the console, and here is the data set. So it's on a folder that's called training folder on my PC. So I'll just quickly navigate to the training folder, browse to training folder. Here's it. Here's my training file. So I just want to check the contents of. Okay, so if you parameters need to be checked here. So the is CSV file, so it's most likely delimited by comma. The next row is slash next line. In some cases, the values are quoted. Comments are highlighted with an hash sign. So it's asking, does the data has a row header? Yes, if the data has a row header, it applies a row header on it. So most of the time, what we normally do, maybe the first column is your row header. Maybe the first column is account number or customer number or phone number. And the row header is the column header means the column header are the features. The row header are the unique columns or the unique column in the data set. So this data definitely has it. But let's open that data set first of all to see what is in the data set. Let's see the record. My desktop training folder. Training. Can't find it. Okay, so my PC is kind of overworking, so it's not responding it's not responding as fast as I want it to respond. But I just want to quickly show you what the data looks like before I even load it into 9. Oh, sorry, I'm in the wrong direction. Okay, so here is training folder, and here is the file. I'll disconnect to share my screen so that you can have a glimpse of what the file looks like. So I'll disconnect this. And then I will show you what the data looks like. Desktop. So from my desktop, you can see this. Okay, so here is the data. Here is the data set. Please confirm if you can see my screen.
Yes, sir.
Okay, great. So this is like the customer ID, unique customer. This is the unique customer ID. That is the so this is the row. This is the row header, and this is the row header, and here is the column header. So this data has the number of accounts. So for this customer, how many accounts does he have? What is the category of this customer? What is the segment of this customer? Vintage is the number of days that this customer has been banking with us. This one means that whether the customer has email address or whether he subscribed to email address or not, or whether he unsubscribed to receiving emails from us or not. This is the occupation of the customer. This is the city of the customer. This is the number of dependents of the customer, and so on and so forth. Even in Nigerian banking system, they can collect all of this information. So these are like the global, some of these are like the global variables. These are like the global variables. Some of these are like the global variables. Why these are the monthly variables? The credit transaction in month 1, the debit transaction in month 1, the ATM credit transaction in month 1, the ATM debit transaction in month 1, the branch transaction in month 1, the branch credit transaction in month 1, the branch debit transaction in month 1, after you are done with month one, you can go to, after you are done with this channel, you can go to ATM channel, then go to internet banking channel, go to USSD channel, go to mobile banking channel. For month one, when you are done with month one, you go through everything again from month two up until month three. So when you are doing all of that, of course, you can imagine how much data you would have accumulated over time. So yeah, so this is like a data set that we want to use to demonstrate this particular example. Then the next step would be, so what I did is that because the data set is in Excel format, I called Excel reader and I double clicked on my Excel reader and I pointed to the location of the file. Then I set all of these parameters. If it's database, it's going to be different for a database. If it's Excel, it's also going to be a little bit different from Excel. I click OK, then I can compile. So compile means just to see if there is anything wrong in the format of the data. But that is showing green means that the data is fine, is clean for what I want to use it for. That is number one. Okay, so the process is very long, but let me go to the end. Then I'll now come back to the beginning. So there's an example here under analytics. This is a classification problem. So let's look at the decision tree classification problem. Okay, so let's hope this is going to come up. It's actually taking so much time. Okay, so this is the first. So if I also bring up this, so for that data that you saw, that data must have gone through staging process and data preparation process. You know, that data has gone through global and monthly KPI selection process. Maybe what has not been done on that data is feature engineering. So if I want to do feature engineering on this data set now, maybe I want to say that, I want to create a new feature, say net inflow. I'm creating a new feature. I want to call this new feature net inflow. And this net inflow so let me call it net inflow for month one, net inflow for period one. And that net inflow is equal to the credit transaction minus the debit transaction. That is equal to the net inflow. So I've created a new feature for everything. So these are new features I've created. So the net inflow for this one is minus 20,000, minus 200,000. The net inflow for this one is about 252,000. So I created a new feature. I can also say maybe what is the proportion of the ATM transaction? What is the proportion of ATM transaction to ATM withdrawal to the total debit transaction? So I can go on and create features by intelligently combining these different data sets. And it's a function of my domain understanding. So I just did one single feature engineering. I created only one single feature. So I'm saving my data. So after saving my data, I want to go back to this and reload it. I want to reload it. I'm reloading the data, apply. No, it's saying so there are changes. Refresh. I want to refresh the data. Let me see. Is there a function for refresh? Reset. Okay, reset. So now I configure. Okay. Apply. Okay. Then refresh it. Execute. So in this new node, if I click on view table, so here you can see the net inflow that I have created. The new feature is now reflecting net inflow. So you can go on and create as many features as you want to create. Okay, so let's go back to this. So the next thing is to do pre-analytics. So that pre-analytics, of course, it's your Power BI or Tableau you use to do those pre-analytics, essentially just to analyze the data, to check the distribution, maybe as you have in this case. You have the occupation distribution of the data, the number of account distribution in the data, the category distribution of the data, the vintage distribution. Okay, vintage, we may want to convert it into something else. So I want to create, say, tenure. So tenure means like the duration that the customer might have been banking with you. So it's equal to this divided by 365, for instance. So that means this customer has been banking for 365 years. So I have tenure. So let me now create tenure band. Tenure band. So tenure band is equal to if. So here you now use your if statement. If it is less than 0, if this is less than 1, then what you do, if it's less than 1, then you say less than 12 months. That is the band. Then if no. So I'll do this. This is equal to if no. I just want to create a nested loop. So I'll do this. Then call. Somebody wants to teach me Abi. If.
I was about saying something that after
Don't worry, I can do it.
Okay,
So
okay.
S2, if it's less than, say, 3 years, if it's less than 3 years, it's going to be more than 1, less than 3. Then again, I put another if inside it. If it's less than, say, 6, so it's going to be more than 3 and less than 6. And two more. So if it's less than 10, if this is less than 10, it's going to be more than 6 and less than 10. And then finally, more than 10. So we've created that. Of course, you can use R to do that. You can use your R to do that. You can use your SQL to do all of that. So I'll just do this. Then I'll scroll from this to the end. No. So I'll copy this. Okay, so what I've simply done is that I've created some new features. Then I'll save my work. It's going to lose that formula because I'm working in CSV format. So it's going to lose the formula I've created. So then again, I go again and reset this, and then I execute again. Yeah. So if we open this and check the file table, you see that the tenor band is there, the tenor, so all of the additional stuff we've created, they are now there. Number one.
Sorry,
So,
sir.
it
That
asks
other
me,
table you created.
pardon?
Yes, sir. That other table you created is it not supposed to be part of the feature engineering in this flow diagram? Since we
Which
are
other
creating
did I create?
that the T table, like if we're taking the structure of this flow diagram, what that new table we created is not like part of the feature engineering, or is it pre-analytics?
It's no. Okay, no. This is feature engineering. What I just did is feature engineering.
Okay, I wanted to confirm
Yeah,
because you're talking about
So what I
pre-analytics.
just did is feature engineering. So for pre-analytics, what it will now be is that, okay, we want to check the distribution of all these tenor band to so this is just simple analysis. So that is exploratory data analysis. Of course, you would have learned that in other subject that you are doing. But pre-analytics is always very, very important. It helps you to know which variable you should select. It helps you to know which variable you should discard at the end of the day. But I think I don't have time to do a lot of those pre-analytics. So after doing that, the next thing I want to do now is I want to do my variable selection. So I want to do my dimensionality reduction. Currently, I have how many variables? I have let me count. I have about 19. I have about 19 different variables. Maybe I don't want to use everything for my model view. So there's a node that is called linear correlation. Correlation, yeah. It's for feature selection, which is the same thing as variable selection, principal component analysis. So I'm using this to select the features that I want to use to build this model. So you connect the output of this into this. I'm linking the two. Then I now click on double click. So which feature do I want to use to build this correlation? I want to use all of the features. I want to include everything. So I'm including everything into this. Where possible count, it's where that has up to 50 counts in value, possible value count. There are some cases where there will be so many missing values in a variable. If there are so many missing values in a variable, you may probably also not want to consider it where there are missing values. So let's look at this, for instance. If you look at this, there are missing values. There are missing values here. So if there are up to 50 of these values that are here, then I want to use them for my model. But if they are not up to 50, I don't want to use them. So in this case, what this is saying is I'm double clicking to set the parameters here. I'm using all of these variables, all of these variables for the number of accounts. I'm using all of these for my for my linear regression. That is for my feature selection, and where the possible count is, it's great. It's at least up to 50. So I'll now execute this. Execute. It's running it. Okay, I think it's done. So let's see the output. So this is what the output is going to look like. This is not very user friendly. Let me see. Okay, here's the correlation matrix. So this is the correlation matrix. So which means that so how do I say this in very layman language? In a very layman language, the question is what is the correlation between um, between all of these variables that are here? What is the correlation between all of these variables that are in here? Okay, something is missing. Something is missing here. I'll come back to that. Something is missing in my data set, which I'm going to come back to. But in this case, what is the correlation? So for each of these variables, so like this, tenure has a strong correlation with vintage. So this say that tenure has a strong correlation with vintage. The branch credit transaction has a strong correlation with the uh, the total credit transaction. The branch debit transaction has a correlation with the credit transaction also. As at the same time, the branch credit transaction has a correlation with the debit transaction, and so on and so forth. This is saying, so this is like a correlation matrix that is showing how relevant is a feature to another feature within the data set. But the most important thing we are looking for is that how relevant is each of these features to what we are trying to predict. So in this data set, what we are trying to predict is not listed here. So in this case, assuming we are trying to predict churn or no churn, assuming we are trying to predict churn or no churn, so the feature, the dependent variable is not classified here. Every other thing is independent variable. Every other thing is independent variable, but the dependent variable is not listed in here. So there's something wrong with this particular data set because we have the dependent variable, which is what we want to use to predict we have the independent variable, which are the features we want to use to predict what we intend to. So many things to say. So we have the independent variables, which are the variables that we want to use to determine the dependent variable. The dependent variable is what we are trying to predict. So in this case, this data does not have the dependent variable. So we are not using the right data So I think I need to look for another data set somewhere. I should have it somewhere. Let me quickly search for it. Wait. Okay, so why it's slow is because the data is quite huge. So the data is quite huge, and that is why I said there are some specification you have to have for your computer. This is like a 16 gig RAM. This is a 16 gig RAM computer. You can see because K9 is already running. Is Microsoft Team is running. Then I'm also loading some very huge data sets. So more or less it's like slowing down the whole computer, and I'm streaming at the same time, so you can see why it's very slow. But I think I've actually exhausted the time I thought I was going to spend. um, so this is I'm going to leave you with this. We can also continue next week. I think a few things I need to share with you. Oh yes, beautiful. So this data set has so let me just call this. I'll just use this to demonstrate it. Let me see if the time will permit us. But a few things you need to do ahead the next class. You need to download NIME on your computer, because that next class is going to be a very practical session. And then I am going to share a very live data through Emmanuel. I'll share a live data with you. Then you load it on your computer, and then you are going to use that to demonstrate how to build a model. So you download NIME on your PC, and when you download NIME on the PC, go through some of those examples that are preloaded in NIME. And then what we are just going to be doing is to replicate the example that you already have in NIME. Again, as I said, where most of the work has to do, where most of the work is where you have to do your data preparation. You spend like 80% of your time preparing the data and preparing the data again. In terms of building the model with NIME, it's just a few click here and there, and before you know it, you are done. So I will just rename this file xxx train xxx under desktop and churn. So this is the data I want to use. I'll close it because it's not relevant. I'm closing this too. So please ask your question if you want to ask me a question.
Okay, good evening. Good morning, sir. Good morning, sir. Yes. I have a question actually.
Good evening too.
Sorry for that. For NIME, I've used a drag and drop ML platform like this before, and I wanted to ask if NIME allows you use a direct filling form, for example, using maybe somebody wants to use a Google Forms with it, where somebody just fill the form indirectly, and then the model predicts the outputs. That's for my first question. And then
Google
second
form.
question,
Hold on. Let me get the first question. The
okay,
first question is whether NIME can connect to a Google form.
yes, something like that, like collects where you can just, as person is putting the inputs, you already have the variables that person is going to use.
So look at your screen. I'm sharing my screen now. Google form, Google Sheet Reader. Google Sheet Reader. You can connect to Google Sheet Reader. So I've answered your question.
Okay. Yeah, that's my first question.
You can write the output directly to Google Form. And then you can now connect your Google Form to what is that visualization tool from Google that they recently launched? Google, not Google Studio. There's a visualization form from Google that they recently launched that is like it's like Power BI and Tableau. So you can do all of that all together. Your next question.
Okay, thank you very much for that, sir. My second question is the predictions from NIME, can it be connected to something like an API?
So the prediction, you want to write your output into a file. You want to write the output into a file. Then your API can go and read the file. Does that make sense?
Okay. Yes, that does. Thank you very much.
Okay. And yes, you can compile it into an API so that you can just call. You want to just call the prediction. you just want to call the prediction, and then, or you want to like call the API with the parameters to call the API, and then it will just tell you whether a customer will churn or customer will not churn. Yes, it's also in there. It's also in there. You can also explore. There are many ways you can work around it. It's not direct, but you can also work around that.
Okay, thank you very much for answering my question, sir.
Okay, so thank you so very much. I think so I'm giving you some tasks. Some of the tasks I'm giving you: download KNIME, walk through the examples. There's an example, so I'll show you where you find the example. So under KNIME, I'm not completing this. Of course, I expect you guys to do a lot of self-learning on this. So here it's KNIME. Under KNIME, so when you, under the KNIME Explorer workspace, you have examples. So for examples, you connect, you double click on examples to connect and download those examples on your PC. Then under analytics, you see decision tree, example for learning a decision tree. Double click on it, it's going to load it into the workspace. I'm surprised why this is not loading into my PC, but you should load it into the environment, and then you connect. I'm going to give you some data set. You connect the data set into that decision tree learner, and you use it to predict. So I'm going to send you a task, and it's from that task I will continue the class from next week. But this is, I think what I've done today is to be able to take you through the theoretical part. I've been able to introduce you to KNIME, to KNIME and how it works. What I've not been able to do is to demonstrate practically how you can use it to build a model. So next week, I'll just spend maybe another 30 minutes to do that, or 1 hour. Then I'll hand over back to Hope and Kola Wale to continue with you on this. Once again, thank you very much. I hand over back to Hope. Hope, over to you.
Thank you very much. Thank you so much. The classes, I learned so much myself. Thank you very much. And thanks for taking time to take this for us. Thank you. We appreciate. So next class will continue from here, next class. Thank you, sir.
Thank you, Hope.
Okay. So does anybody have any question before we use the next 10 minutes to just wrap up where we were last class? Hello? Okay. Okay, so we'll just go over briefly where we stopped last class. Okay, so we're going to go into how to use decode functions. Then we'll talk about data. Sorry, okay, so we're here. So we'll just run through decode functions. I want to believe you've read through this because it's inside the last document I shared. So we'll just run through it, then we'll go into procedures. But procedures and functions, I would like us to take that after taking the KNIME class. After we finish the KNIME class, then we'll take the procedures and functions. But let's just run through. Can you see my screen?
Yes, I can. Yes, I can.
Okay. Okay, so we'll just run through this in the next 10 minutes. So we have decode functions in SQL. What do you use? What is the decode function and what is it used for? And how is it used? So decode functions allow us to add procedural if then is logic to the query. Decode compares the expression to each search value one by one.
Your Google.
Hello, ma.
Yes.
I've seen your browser.
Oh. How about now?
To your browser.
I still see your browser, ma.
So you can see your browser.
Okay, so so there are different types of arguments. We have numeric types, we have the character types that you can use in using a decode function. So what is the syntax for using a decode function? And just like we have pivots not compatible with MySQL, decode functions cannot work with MySQL as well. It asks versions of SQL you can use decode functions on. So when you're using Oracle SQL or PLSQL, when you're using Oracle 12c, 11g, 10, then GI, those are the versions that you can use decode functions on, and you can also use pivots on. Like, oh, this is not opened. Okay, I want to show you. Okay, I think I've shown you before what Oracle 11g looks like. I have Oracle 11g on my system. There's 10g, there's 12c, there's GI, there's different versions, but these are the versions that are compatible with using these functions in SQL. So how do you use a decode function? What is the syntax? You say when you in your query, after your decode, after your select statement, then you say decode and then open a bracket. So the first thing that comes is your expression. Your expression is the value which has to be compared. It automatically gets converted to the data type of the first search value before comparing. Then the next thing is your search. The search is the value that is compared against the expression. Then you have your result. The result is the value that is returned if the expression equals to the search. Okay, then you you open a square bracket to put that, and then you end it with a default. The default is not compulsory, it is optional. But if there are no matches, the decode function will return default, and if default is omitted, then the function will return null. So it is optional, it is not compulsory. But however, if you did not put default, you have none in your columns where the decode functions, where there are no matches with the expression and the search. So when the expression and the search does not match and you didn't use default, it returns null. So let's take, for example, if you are using Oracle SQL, then you now want to use decode. You say decode, so you select bank name. So let's say you now want to use decode function to do that. You now say decode the bank name. So sorry, the bank ID. The bank ID is your expression. Then 001 is your search. So that means you want bank ID 001 to return SBI. Okay, so, okay, then you now end it with the gateway and the result from banks. So let's assume the bank is the table that holds the data. So that's the bank table. Inside the bank table, you have bank name, you have bank ID. So you are now saying that you want to decode the bank ID 001 as SBI. Okay, so let's look at another example. If then, so let's say you now want to use the if and then for the example above instead of using the code. So this is the code. You can as well use, so the code is, like I said earlier, is used to instead of using the if then logic, you can just use the code function. You can as well use the if and then logic. So if you want to use if and then logic for this code statement, this is what it's going to look like. Then you now have something like if bank ID equals to 1, then result is SB1. If bank ID is equal to 2, then result is ICICI. If bank ID equals to 3, then result is DENAS. Else, result equals to gateway. That is if you want to use the if and then logic. But instead of writing this long step-by-step if and then logic, you just use decode function to return it. The decode, you use the bank name as the expression, the search, and the result. The expression, the search, the result, the search, the result, and then you end that with the final result. Okay. So then the decode function can also use to compare two dates. Say you want to use date range and you want to use, or you want to not only dates, say you want to compare periods, like okay, this period is greater than this period, or this period is less than this period, or this period is equal to this period. You can as well use the decode function. So this is an example of the decode function when you want to return, when you want to compare periods, when you want to compare periods. So you have the code. So the date is the expression, the ABS is the search, and then you have the result. So if date equals to the formula above the formula below equals 0 if date is greater than this one is greater than the 2. So if this period is greater than this period, it's just the same way you have in writing SQL, that you have your case statement where this is greater than this, or where this is equal to this, or where this is equal to this. Just the same logic. Full lines of script. So that's on the code functions. I hope I'm able to pass. So then we have the final decode statement will return the following. So let's say you want to do hours, is also the same thing as what you have above. Say if hours of work less than 1, then return 0 to 4. So this 0 to 4, 0, 0.04, 0.06, those ones are a numeric representation. Okay, so it's not like 0.4, so it's just a numeric representation. Okay, so let's say I want to return a figure. Let's say I want to say, okay, if this person worked for less than 1 hour, let's say the person worked for then you return this. If this person worked above 1 hour and below 5 hours, then return this as well. If this and return this. So instead of that, you can just use this decode function, hours of work plus 3 over 4 and all of that. So you have your expression, you have your search, and you have your result. I hope it is clear. So that is that on the decode function. So we take procedures after completing names. Take procedures after completing names. However, I want you to, I'll jump down to managing users and privileges. This, I will just run through this in 2 minutes. So managing users and privileges, if you are using SQL and you want to manage users, you want to manage privileges you give to the users, how do you do this? So there are two commands. We have data control commands, that's what you use to manage privileges, and then you have the transaction control you use to manage privileges as well. You use that to manage users and privileges. So the data control language is the commands used to control privileges in the database. So you have the grant and you have the revoke. So let's say the way you created okay. So the way you created the table for graduate training class, let's say I don't have access to the table, or we work on the same database but not on the same schema. I have another schema, I have my own, and then I want to access the table. All you need to do, instead of me recreating the table afresh, since the table is already existing on that with another user, what I simply do is I'll say, okay, grant me access to the table. The moment you grant me access to the table, then I can access the table. And any day you decide that, oh, maybe I've done something on the table and you don't want me to do it again, you can revoke the access. That is what it is. So the grant is used to grant privilege to the user, and you say the syntax for that is, you say grant, maybe you want to grant me access to be able to select and query the table. You say grant select on the table name to op. Okay, let's say it is not, you don't want me to be able to select, you want me to be able to load more additional data into the table. You say grant insert into the table. Maybe you want to grant me access into your database. You know, you created a database, so you want to grant me access into your database. You grant me create any table into the local host. That's your database name. I just use that as local host, but that is the database name. Okay, so the same way you grant access is the same way you revoke the access. The only thing that changes the grants and then the revoke. If you want to revoke, if you grant me select access and you want to revoke the access, you just say revoke select on table from op. So instead of to, then you say, instead of grant onto, you say revoke on from. So that means you are taking back the access that you grant onto me. Then we have the transaction control language. So that transaction control language helps you to, it's just like do and undo, like save and unsave, like you have do or redo and undo. So you have commit, you have rollback, you have save points, you have set transactions. So what is the commit? The commit saves all the transactions to the database since the last commit or rollback command. So if you run a script and you commit it, that means you are saving it. If anybody queries that table, if you load a table and you did not commit it, there's a probability that another person can query the table and not see it. But you will still see it because you're the one that creates it. Okay. So each time it's actually advisable, each time you run a script, you load a table, you create any access, always commit so that you can, it's just like you are working on your system and you are saving your work. If power goes out, and then you can come back and still have your data where you stopped before the power goes at the point you saved last. So rollback is just like you say Control Z or undo. So let's say you have commit, you have saved something, and you discover, oh, there's an error. You can roll back to what you did last. So the rollback command is used to undo transactions since last commit. Then we have save point. The save point command creates points within the group of transactions in which rollback. So the save point, when you want to use save point, you say save point, then the save point name. That's the syntax for saving a save point. If you want to roll back a save point, the same way you create a save point, you can also roll back. The same way you say roll back to the save point name, just that way. Okay. So we now have the set transactions. The set transactions enables you to give a name to the transaction you've done. So if you want to say you want this, you create a table and you want it to be read only, you want it to be read and write only, that's the way you use set transactions. You notice that sometimes you open some Excel documents and they will tell you, you open some Excel files and you see something like you can only read, you cannot do any modification. So it's just like setting security on your files, locking it, and so as to avoid any external person tampering with your data. So if you want to do that, you can set transactions, set it to either read only or read or write, and then that is the only access that's the only thing that will be able to, that will be done on the data. Is that clear? Hello? Hello?
Yes,
Yes,
ma'am.
we're here.
Yes, ma'am.
Okay. Okay, so do you get that? So we'll continue from, after we finish the 9 class, we'll take procedures and SQL, procedures and functions, and then ETL processes. So that's all on managing users and privileges in SQL. So any question before we call it a day? Okay. So in the absence of questions, please do have yourself a wonderful day, okay?
Thank you very
Thank you, ma'am.
You're welcome.
Thank you, ma'am.